Hello, 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 hello. Okay. Sorry, it seems that the audio was not working well and properly, so I'm going to repeat everything. Okay, first of all, what you have to do in this session 4, here you have to, on data, you have to unzip this and this one. Okay, you have to unzip this and this one because this is the data that is going to where where we are going to work with. However, this data is here as a compressed version, so we need to expand it. Okay, and then let's open the QGIS, and we are going to open the raster files. If you see that the raster files are in the format of sgrd, and what does it mean, the sgrd? That means that it means that that it is that is a file from GIS. So let's work here. So on home, on the course material, let's go to session 4, let's go to raster, and let's open this and this one. So in one we have the channel, the digital elevation model, and in the other one we have the channel network. If you are here with me, please type yes 1. If you are here with me, please type yes 1. If you are here with me, please type yes 1. Okay, great. Okay, so let's continue. So on the processing tool, we are going to work with watershed basins. So watershed basins from GIS. Okay, so let's open watershed basin from GIS. Okay, and here we are going to work with elevation. That will be our field elevation. Our channel network will be this. Okay, and then let's work here. The minimum size will be 100. And what does it mean? Okay, the minimum size, here is where you can define the size of your channel network more properly, because with 100 means that the minimum I mean, the first channel network will be the cells that has a capture zone higher than 100. Okay, that is what this mean. That is what it means. So if you have a on the channel network, you have a cell that has a accumulated value that is less than 100, so it means the capture zone has less than 100 cells, it won't be represented as channel network. Okay, as long as this number will be higher, your channel network will be shorter. Okay, so and then we are going to use this as on the save it to file. On the course folder, let's create session 4. And here on section 4, let's create another one that is rasters. And then here on rasters, we are going to call it this HT GTM2. This is the combination. It has already been cut is in UTM basins, and this is 160. I don't know why it's 160. Should be 100, but let's see. 160. Okay, so this will be the name of, and this is a SDAT because this will be this is an SDAT, so that means that this is a raster file from Saga. So we run it and then we wait. Have any questions? Yeah, that really depends. Okay, there is a great question from Manal that says, do you have an idea of how to choose this number? And that really depends on how many. For example, if you're working with QSWAT and then you want to split your, or like PRMS, that you want to split your basing in, for example, in 500 subbasins. So for 500 subbasins, you have a different minimum size that you have it for 5 basins. So actually this comes from the how many sub basins do you want to have from your basin. Okay, yes, so this is, as you have seen here, this is the result. So this is the basins that has at least 100 cells of accumulation. Okay, and this is how it has divided. If you put 1000 cells, or maybe 100,000 cells, you will have less basins. Can we choose the basin by Strahler order? This is really similar to the Strahler order, because the Strahler order actually divides your channel network in 10 intervals. Okay, so what it does here is that you can actually, here you will have different Strahler order, because you will have, if you have seen what we have done in the other part, you only have 10 Strahler orders, because you get the number of basins from the Strahler order. But in this case, you have you define the basins, and from that you define your Strahler order. Actually, I don't know how to redo the Strahler order from here, but you will have orders higher than 10. Okay, any questions? If you are here with me, please type yes too. If you are here with me, please type yes too. Okay, so here from according to the exercise, we open upslope area, and as well we open upslope area. Okay, and then we are going to polygonize. Why? Because here you have a lot of basins, but we don't want a raster. What we want is a shapefile. So we are going to polygonize. If you are here with me, please type yes too. Great, and then we go polygonize. Polygonize. And what we are going to polygonize is the basins. Yeah, band 1, that's the same, and this will be poly. So here, save to file. On the course material, we are going to create a shapefile, because this will be a shapefile. Okay, in session 4, and this will be AST GTM2 UTM with basins 100 60 poly. Okay, because it will be a polygon. Okay, and that's it. We are going to polygonize our basins. Okay, so what you have here, you will have it as a polygon, and this is really powerful when you want to define your subbasins for your basin if you are doing distributed hydrological modeling. Okay, if you are here, please type, well, I hope that you are here. Okay. Okay, great. So what we have here, yeah, is okay. What we have here is a shape file. Okay. What it will be the purpose of this exercise is we have a basin, but we want these ones that are inside the basin, and of course that we can do it manually. We can cut it manually, but there is a way where we can do it with just commands from QGIS. Okay, so we hope that you are here. I'm going to cut this, and then if you have any question, let me know. And then we enter here, and then we go to the attribute table. Okay, we go to the attribute table. We are going to edit, and then we are going to insert a new column, because this is the DN, and the DN is kind of the digital number. Okay, but we are going to use another one that is called the create new field, and this will be ID. Okay, because this will be the order of the polygon, not the value of the polygon. Okay, dn is the value of the polygon, but what we are interested is in the order of the polygon. So here we do okay. So, and then we have the ID. So this is the value of the polygon, and this is the order of the polygon. We are interested in the order of the polygon. For that, we have done it ID, and then here we have done here $ID. Okay, if you are here with me, please type yes 3. If you are here with me, please type yes 3. Okay, let's continue. And then we do not need this anymore, so we are going to delete this column. How we do delete this column? We need to be on edition, and then with that we delete the field, and we select this, because we are not interested in the value. We are interested only on the order. Okay, so this is the order. So with that we can delete field, and then we delete the DN one. Right. And then we can save, and then we can get out, or we can get out and it will ask if we save. Okay, so here we can save, and then we can get out. We can save, and then we can get out, and then I can close. Okay, great. What I'm going to do next is that I am going to get the centroids of this. So they say we just type centroids, and then we have here polygon centroid. Okay, then we have here polygon centroid, where we have here the polygon, and the centroids will be stored into file as a shape file, because this will be poly, and then this will be center. If you need more time, if you want that I repeat, I can repeat, don't worry. Okay, if you are here, please type yes. Yeah, Manal, there is a great question, Manal. The order of the polygon means the. Yeah, great question. I never thought on that. Well, I mean, and I think that the discharge point will be number 1. The next one will be number 2, and this is how this will be rearranged. Okay, yes, it has to be it has to be, or it's just the distribution of polygons. Well, to tell you the truth, I never thought on that. Okay, if you are here with me, please type yes for. Okay, so these are the centroids, and then what we are going to do here on the centroids, we are going to as well go into attribute table, and then we have the ID. Okay, and this ID, yeah, is the same as the, I mean, this one corresponds, I mean, like I will tell you, for example, here in any basin, yeah, I go here and I select this one. This one is ID 166, and then if I go to the polygons, this one is as well 166. So this order corresponds to the order, or the order of the point corresponds to the order of the polygon, and this is something that we are interested to know. And then we are going to do a strong, and usually lately I haven't been so, but at the beginning I did more on that, is select by location, select, and then this is select by location. Here this is select by location. Okay, great. And we are going to select the centroids that are intersect our basin. Okay, and then you will see how those are. How are those? We have the, I mean, we can do that with the polygons. What is the problem with the polygons? That if you, we are going to see that there are some border polygons, and they are the, sometimes, I mean, the could be that the filter works well, but sometimes, because actually we will need two polygons that intersect. I mean, we can do this as well with the polygons, but it's, I mean, the centroid is definitely inside the polygon of the basin. Okay, yes, if you are here with me, please type yes 5, because we are going to create a selection. Run. So, and what we have done is that we have done a selection. We do a zoom to the extension, and then we just have the centroids that are inside the upslope area. The other centroids won't be there in this selection. Okay, great. And then what we are going to do here from this selection, okay, if you are here, please type yes 5, because I have to close this, and then I have to add a new field, and then I will put 1 to the selection. Okay. Uh, what is the purpose of this subdivision? This subdivision was done in order, I mean, there is no clear way, I mean, this is the basin, and then we want to select the basins that are inside the upslope area. Those are the subbasins, and then we want to select the subbasins that are inside here. But actually, the filter, the select by location, is not so well if we want to do polygon to polygon. So that's why we get the centroids, okay? And then from the centroids, what we are going to do is we are going to define, okay, by sure, okay, we are going to define, for example, if you have seen the polygons, our basin has this polygon and this polygon. However, only these ones are inside, because this one is partially inside, but actually is not so inside. Okay, this is a criteria from us. So what we are going to do, once we have it selected, okay, once we have it selected here, what we are going to do is that we are going to export, and then we are going to select feature as. Here we are going to export, and then we are going to select feature as. Okay, and then here we are going to save it as polygon centroid, and then here we are going to set 3D, no, cell. This one will be selected, yeah, because those are just the ones that are inside. Okay, and it will be a srich shape file, and then we see, and then this one has to be on only selected. Why? Because if we do that, all the points that are not inside the polygon will be omitted. Okay, and then there is there is a question. Okay, I will. Okay, and then we have only the points that are inside. There is your friend Eris is true. There is an issue here. On the basin definition, we have this. Okay, there are some basins that turns to be that are only 1 meter, that are only 1 cell. Okay, and this could be related with the field sinks. This could be related with could be related with many other things. We can omit them, however, and then we have to see how we fill the whole, okay. In our case, we are not going to do that, but it's possible, okay. Or maybe we can work with the parameters of the field sinks as well, because it might be that the field sinks is too strong and is deforming so much the base. Okay, great. So now what we have here is a shapefile that has only values for the basin. Okay, great. And then what we are going to do is we are going to open the attribute table. Okay, no. Okay, let's delete this, let's remove this, or let's remove this, and let's go back to this one. Okay, so here we have the selected. So what we have done, yeah, remove the other one. Okay, I made a mistake. This is the polygon centroid. Okay, and then we are from the upslope area, run. Okay, and then we have this. Okay, what we have it is okay. Okay, and then here in the polygon centroid, let's go to attribute table, and here we are going to, and this is the ID. Okay, here we are going to add a new field calculator. Oops, sorry. And then here we are going to define a value that is select. Okay, select. Okay, and then here this one will be 1. And what this means that it will apply only for the selected ones. It will have a value. This field will have a value of 1. For the rest, it will be 0, known. I mean, not a value. Okay, let's type OK. And then you will see that you will have some values for. You will have some values just for ones. Okay, great. Yeah. Okay, if you are here with me, please type yes 6. If you are here with me, please type yes 6. Okay, great. Okay. I will remove this in order to provide support for. Okay, great. So here we have the selected values. Okay, these are the centroids, these ones are the selected ones. Okay, yeah, but this is just a selection. I mean, this is not an attribute, this is nothing, this is just a selection. This means that these are selected and these are not selected. Okay, however, what's happened here, the problem that we have to store somehow this selection, and then one way that we can store this selection is on an attribute. Okay, an attribute can store the selection, and this will be a clear way of how with this selection how we use it in order to do further analysis. Okay, so how we are going to store this selection? Just go to here to open attribute table. Let's go here to field calculator, and let's do something only for the selected ones, and this here will be select, and this will be an integer, and this will be 1. And what does it mean? It will mean that only the values that are selected, meaning the values that are inside the basin, are the ones that is going to have the attribute of 1. Could be an attribute of true, could be an attribute of something, but those are the ones that fits that selection. Okay, is that, I hope that this is okay, Manal? So here we have the selection, and for the other basins or the other centroids that are not in the basins, we have nothing on this attribute table. Okay, we get out and we save. Okay, if this is okay, we can go forward, or whether I can keep. Okay, great. So we can do as well here, we can get the centroids, I mean the coordinates of the centroids, and this is could be helpful for you as well. How we get the coordinates of the centroids? For example, here we are going to create, okay, so we are going to do a deselection. What this means a deselection? So we are going to deselect, okay, so no centroid will be selected, and however, it doesn't mean, I mean, from some basins the attribute is 1 and the others are null. I mean, so the change is already done. So here we are going to open an attribute table, and then here in open an attribute table we can have the x centroid, and then there is centroid. Okay, if you see here, I use 8 characters I use 8 characters as the header, because I don't know right now, but some years ago the maximum number of characters for the field was 8. I mean for the name. Okay, so that's why I only get this, and this will be $y, and this $x, and this capture the coordinate x of the point that will be the centroid of the basin. And then as well here I do new field y centroid, and it will be $y, because it will capture the y of the basin. Okay, if you are here with me, please type yes. 7. Okay, great. What we can capture as well is the elevation of the centroid. The elevation of the centroid is not actually the mean elevation of the subbasin, but it's a value that it will be kind of will fit, and I think it will be closer, or I think that it will be representative of some feature of the basin. So we can take this as well, we can capture this as well. And how we can capture, okay, so then, okay, let's get out of the edition, okay, and then we can capture with the point sampling tool. We are going to use the centroids, okay, and then we can capture here the UTM. Okay, here we can capture the UTM, and this will be on the course folder, session 4 shapefile, and this will be a shape, not a geopackage, and this will be 3D because it will be the centroids, and as well will be 3D because it will have the elevation. Okay, it will be 3D because it will have elevation. Okay, with that we can capture the elevation of the subbasin. Okay, great. Okay, and here we can, on fields, we can call it elevation, elevation. Okay, great. So this will be, we can capture this and the elevation. Okay, if you want to keep the you can keep it as well, the ID, the selection, the centroid, and the elevation. Well, why? Because if you can see, these are the original attributes, and this is the elevation. So here will be the ID, the selection, the centroid, and it will have the elevation as the last one. Okay. Yes. Okay, we can have the ID, the selection, the elevation as the last one. Okay, great. Okay, and the okay. No, just this and this, because this one we don't want it. We just want the just from the polygon centroid and the UTM. Okay, if you are here with me, please type yes 8. If you are here with me, please type yes 8, because we have from the original, from this shapefile, all of these fields plus the elevation from the raster. Okay, so then we will have ID, selection, X centroid, Y centroid, and elevation. Okay, and these are all the information from the subbasins. And then this is really helpful when you do your hydrological models, because when you want to define subbasins, you have lot of tools in order to define those subbasins, plus the elevation of the raster. Okay, who else is here? Okay, with that we create okay, and then it performs the operation for all of this. And what we'll have here is that we have the ID, and then we have the centroid, the elevation, the centroid of the basin. However, those are just the centroid and as well the elevation. So what we are going to do next is that we are going to join. So what we are going to join is that because this is just for centroid, but I want that this information will be here on my, this will be here on my basin. I mean, I want that the information appears here and not on the basin. So how we can do it? We can do it like this. Okay, so we are going to join tables, and in order to join tables we have to see which are the attribute that is being shared among them, and this is the ID, because this ID is the same as this ID, and with that we can join tables. Okay, joining tables is really easy, so just right click properties, joins, and then we add a join, and then we are going to join from from the centroid 3D, because we want to get the elevation as well, and the field will be ID, and the target field is ID with ID. It can be different, but I strongly recommend it to be the same. And that's it. And the prefix, it will be centroid. You can do this because it will be all this prefix. You just go cent, because those is information regarding to the centroid. Okay, this is information regarding to the centroid. Okay, and that is apply. Okay, and what does it mean? What you have done is that you have here, besides the ID, you have as well this, I mean, besides the polygon, you have as well you have something that is related, that if you are working on inside the basin or outside the basin, you have the centroid, and then you have the elevation for every ID. Okay, that's amazing. However, what we want is just to select the basins that are the sub-basins that are inside our slope area. And how we do that? Maybe you find this procedure long. However, it's not that the procedure is long. Yeah, in fact it's long, but something that it shows the procedure are the tools where you can do this, but for every process that you might find and you might encounter while doing your um, special your hydrological analysis. Okay, you know the tool. I mean, here we have used lot of tools, and this was the purpose of doing lots of tools. Maybe I can do this in less amount of steps. Okay, however, this is just to show you the tools. Okay, so what we can do here is we can do a filter. Joined fields cannot be filtered. Okay, don't worry. Okay, so I cannot do a filter because this is a unit tails. However, here we can, and according to the how do a filter? Okay, so in order to do a filter, I have to save it. Okay, so here I have to save the join. So here we are going to export save feature as. It will be a srchef file, and then here will be centroid polygon union. This is in order to save. Okay, we have to save it. Okay, and then we are going to save all of them. Okay, we are going to save all of them because we need to save it in order to do our next step, and our next step will be, okay, so here we have this. Okay, and let's look, please look at what I'm going to do. I'm going to do a filter, and here I'm going to do a send select that is equal to 1. So what is this? Look, please look, and then we do it again. Is that here I'm going to select only the sub-bases that are inside, because this fits that the centroid of those sub-basins are inside the polygon of my basin. And actually, if you see here, this is quite not so perfect. It's not so perfect in the detail, but the result is great. Okay, so I'm going to do it again. So I just clear. You have this, okay, that is the same sub-basin polygon, and then you can do here, you can do filter, and then you can send select, that is the attribute that shows if the centroid of this sub-basin is inside the basin, is equal to sample, and then you have two values, whether it's null, none, or whether it's 1. So in our case it's 1, and then just type OK, and that's it. Okay, if you are here, please type yes 9. If you are here, please type yes 9. Okay, great. So what we are going to do next is that we are going to do right click, and then we are going to, yeah, we have done this, and then we can, we have many features of our sub-basin. We have the centroid, we have the elevation, and then we might need the area, because as well we are interested in the area. So how we are going to calculate the area? We are going to go to toggle editing, we go to the field calculator, and then we create a new field that is called area, and then here just type $area, and this will provide you the area. Since you are working in UTM, it will provide you the area, well, here as this is in meters, square meters, and this is an integer. Okay, so here you have the area. Okay, so great. So we toggle editing, and then we save. Okay, from that we can do lots of selections. Okay, so what it will mean that we can do some selections. Okay, first, okay, so there is a concept to explain here. Okay, what you have here are the polygons that are inside the base. the sub-basins that are inside the basin, because there are other basins. Okay, that's great. Yeah, but then what you need next is to, but this is related to a filter, because you have a filter here. So I mean, and the concept is, what you are seeing here is just a filter of a whole shapefile. This is not a unity of the shapefile. This is just a filter of a shapefile. What we need here is to save this as another shapefile in order just to have the subbasins of the basin, okay, as an element, okay, because right now you have the subbasin of the basin but as a view from the other basin. Okay, interesting, isn't that? So we get export, we say feature as, and then here we do AST concat polygon union, and then here we are going to do underscore query. Okay, underscore query. Okay, okay, great. Yeah. And then here let's go to filter, and then we can do interesting things. For example, I want the areas that are higher than 500. So in this case is 50 acres. So for 10,000 meters is 1 hectare, 50,000. So let's say I have 17 rows that fits that. Okay, and that the area is less than 100 hectares. So this is, yeah, so this is test is only 0, so I don't have, no, 1 million, because those are the ones that are higher than 10,000. The areas that are 500 hectares and less than 1,000 hectares. So say test. Okay, I have 17, and that the elevation is higher than 2,000, for example. And then I want to test, and I have, okay, I have 15, but as well I want that the elevation, it will be less than 3,000, and then we have only 13. Okay, so here we have some labeling, or here we have some we can do some querying, but this querying is really powerful because it can show you many stuff of what is going on with the basins, and then you can select some basins according to soil, to elevation, to area, to perimeters, and so on. Okay, can you change the unit of the area? Yeah, it's possible, but what you, okay, I just to complete this part clear, I will change the unit of the area. Okay, so how? So I get to the polygon, to the query, I go to the polygon table, and here I go to field calculator. Please look that I don't need to be in toggle mode to go to the field calculator. Okay, so I'm going to create, so this will be area in hectares, area in hectares. So what is hectares? Hectares in hectares, and in, what is the diminutive of hectares? Each in hectares. Okay, so and this will be the attribute will be area as the field of area divided by 10,000. Okay, so this is the area that this area is in square meters, so divided by 10,000 will be the area in hectares. So okay, so and then with this, instead of doing the querying with this value, you can do the querying with this value, and this is in hectares. Okay, but however, since this you are working in UTM, your intrinsic area is always in square meter, but with a field you can work in other units. Okay, so that's it for now, and if you have any questions, let me know. Otherwise, we are going to, yeah, we have to recalculate it, because since you are working in UTM, always you are working in square meters. Okay, but it's not such a big deal to do that. Okay, so if you have any questions, let me know. Otherwise, type yes one, because we are going to close this, save as, and then here on session 4 we create a new folder that is QGIS, and then here will be part 1, and then if you are here with me, please type yes one, because we are going to do, please type yes one. Yes, so we are going to do a pause. 7014 to do the next one. Okay, great. So I'm going to take out the audio and go back in 10 minutes. Okay, okay. I took some minutes. Sorry. Okay, we are back. Okay, let's do the next exercise. Okay, so let's do a new project here. And in order to do this exercise, we need to have a software that is called LAS Tools. Okay, I will show you how to use it. Okay, and then what we are going to do now is that we are going to delineate urban watersheds. Okay, and those urban watersheds are done with the from LIDAR data, and some cities have LIDAR data. It could be that your city has LIDAR data or your country has LIDAR data at some extent. Okay. Um, and why to use LIDAR data? Because LIDAR data has point clouds, and point clouds is kind of dense distribution of points around the surface, where we have spatial resolution and vertical and horizontal resolution that much higher than it was possible with normal digital elevation models. Okay, in order to do that, we are going to use for a website that is available under this link, has no requirement. Okay, and here what we are going to use is we are going to use here where we are going to use here a blob shapefile, and this in this shapefile we are going to use a zipped shapefile. That is, where is this zipped shapefile? The zipped shapefile is in the course material session 4 practice data, and then here you have on shapefile you have this AOI, area of interest 2, as a zip file. Okay, you just have to select it, yeah, and it will be bringing, okay, and it will look for this polygon. Okay, if you are here with me, please type yes too. Okay, this is the link here. If you are here, please type yes too. Okay, if you are here, please type which shapefile I have chosen. Okay, I can do it again. Okay, on the course material, on session 4, on practice, on data, we have under shape, we have this is a zipped version of this shapefile. Okay, this is a zipped version of this shapefile, and then here I have looked for that, so upload shapefile, and I have selected on session 4 this AOI shapefile. This is the zipped version, because a shapefile is around five files, so this is a zipped version. Okay, if you are here with me, please type yes too. If you are here with me, please type yes too. Okay, great. So here we go to where we go here, LIDAR, elevation LIDAR, and then we are going to use LIDAR point cloud, okay, and then from that we are going to do last last this is the original uh, folder, and last this is the zipped version of this one. So we search for products, so you just have to do click here and click, and then we search for products. Okay, great. And then for this extension there are two datasets. First there is the San Bernardino area, and then here I can see the footprint, and actually the filter is not that great because actually it provides you areas that are inside the polygon but are close to that. And there was another one that was related to the wildfire that they have it on 2018. Okay, so we have to select, for example, just the San Bernardino data. So footprint, this one, this one, this one, this one, that's this one, this one. Okay, for example, then you will look for this. Okay, and then if you, for example, if you want to download, for example, I want to download one of them, I just have to download the last file. Okay, yes, just have to download the last file. And then it will download through browser, I guess. Okay, and it will download, it will start downloaded all the file. Okay, so this one is once again, for example, another this one, download last. Why I cannot download? Why I cannot download? Let me check. Could you download? Once again. No, actually I don't have to register to this one. I didn't have to. Okay, I will have to add to the how say the shopping box, and then here on cart I have to download a CSV file. Okay, and then what will be appear on the CSV file that has changed, huh? As a CSV file, and says okay, you do. nothing. Okay, I will use Chrome. I don't know why I cannot do it from here. I'll download last. Don't know why I cannot download now. Okay, there is no, I mean, you can play around with this because it works that way. Yeah, but there is no problem. Why? Because we have already downloaded. Okay, so we have it here. Okay, under documents, on the course material on session 4, on practice, on data, we have here the last files that we are interested in. Okay, so these are last files that actually come from the website. If you could download it, there is no problem. I couldn't. Okay, but okay, so these are the last files. Okay, great. Sorry. And then what I'm going to do next is that I'm going to open on QGIS. I will go to AOI, and then this is in 983. Okay, and this is the same polygon. Okay, and then I will add a quick map service on Google, and then Google Road. Okay, so here we have my basin and Google Road. Okay, and then what we need as well is we are going to work with Last Tools. Last Tool is a plugin for LiDAR that is really powerful when you work with LiDAR. I mean, it's otherwise you have to do some coding or working with other stuff that is, it's a pain. So let's go here to plugins, manage and install plugin, and then here we are going to use the last tool. Okay, so here we go and use the last tools. Okay, here we go and I use last tools. Okay, I have already installed it. You can install it, I mean, just I can reinstall it, you can install it as well. That's right. Okay, and then what else are required is say, okay, this exposes the last tools, however you need last tools on your computer. Okay, so you on a browser, okay, on a browser you download this. Okay, you download this, you just download it. Okay, we download it. Okay, you just unzip it. Okay, it's all downloaded. You just unzip it. Yes, and then my suggestion is that you put last tools here on your C. Here you find my C. Yeah, here what you are going to download here, you just unzip it and place it here, because this is the default place where this is going to look. For example, if I go to processing and then I go to options, here on providers, last tools, it is on C, last tools. Okay, C to point slash last tools. If you are here with me, please type yes, only the files that are included within the shape file. Okay, but don't worry, because the files are already downloaded. This is just to show you the procedure. Okay, if you are here with me with the last tools installed, please type yes 5, yes 3. If you are here with me with the last tools installed, please type yes 3. Oh wow, you are using Mac. Oh, that's an issue. That is an issue. Why is an issue? Because you this is for Windows. Let's see that there is a last tools for Mac. Uh, Homebrew, Brew Star 1. Oh, you have to do it with the visualization. Uh, no, the problem with this one is that is on Windows. You cannot do it with Mac. Sorry. Yes. Okay, let's do it. Okay, so don't worry, because after some file, when we do the digital elevation model, then you can join this, or I don't know, if you using VirtualBox, you can do it as well. Okay, so let's do our, so here we have our polygon. Okay, and then okay, so we can go here to last tools, and then we can do it last view, because we can view our point cloud. Okay, so here on we select any last view that it is. Okay, so on the course material, on session 4, on practice, on data, we have last, and then we open the first one. Any one is okay. So we can view, what is inside our, and then you will see that here you can open a point cloud. Okay, and then you can play around with the cloud. Okay, so and then you can see that there are different values, okay, or different colors, and each color depends to a classification. Okay, for example, if I do right click and there's a color by render only ground is number 2, so this is just ground. Render only object, this is object. Render only building, those are the buildings. Render only vegetation, this is the vegetation. Render only mass points, those are the mass points, and so on. Okay, so these are the different point clouds, and then we have 8 of them. Okay, and then we can get last info, and then what is last info? That we can get some statistics about the last file. So with the last info, we select any one, yeah, and then just type run. And then it says how many points do you have, which was the instrument, and so on, and the extension, and so on. And this is the classification. So you have that amount that is unclassified, ground, low, high, building, noise, and key point. Okay, so this is what we have. So this is just to show you which are the different types of information. Okay, let's close it. Then we can do last merge, but we have to be aware of something. Last tools is not free. Okay, last tool has some issues with the license. Okay, so what does it mean? That for any point cloud, you can do everything that if your point cloud is less than 1 million points. But if you have more than 1 million points, you should have the license. However, there are a couple of steps inside last tool that allows you to work with with splitting your point cloud to 1 million, and then from that you can complete the procedure. Okay, so that's why we have last merge. Last merge will do it for the whole, will create a compound of 72 million points, where last merge pro actually what it will do is that well, no, not this procedure, but other procedure, what it will do is that it will split all of these merge in separate point clouds of 1 million points. Okay, so in this case we open a directory. So here in data we select the last, because all of the last will be in our file, and then just we'll create here save to file, and here on the course folder, we create a new that is called LAS, and then here we are going to call it LAS San Bernardino La merge. Okay, so this will be the merge of all of these dot las. San Bernardino merge dot las. Okay, so with that we create a merge one, a merge version of our process. Yeah, this is a merge like this. And if you see, if you go to the session 4, no, on the course material, on the folder material, here on last we have, this is the file that is being created. Okay, okay, here we have is a big file, it's around 700 megabytes. Okay, so and then we have to split it. Okay, if can you calculate the area? Yes, with the last info you can have the coordinates of the extension, and then from that you can calculate the area. Okay, so and then we are going to do last split. Okay, because we, due to the restriction of the license, we have to split this huge we have to split this huge last file, the one that we have created on the course material, on the course folder, on the exercise folder. Last, here we have our last. Okay, and then we are going to create it 2 by flight line, and then we are going to split in 1000 points. Okay, this is, we are going to split in 1000 points, and then we are going to save in the same place, merge last, but these ones will be called last split. Okay, with that we split our data in this big, we split this, I think that it has 56 million of points, it will split in 56 files, something like that. Okay, so we can run it. And then you will see that this is on the exercise folder on last. This is number 1, number 2, and each file is 1 million points. Okay. Okay, so here how many files do we have? We have 62 files. Okay, great. So what are we going to do next is, okay, we can close this, is to use, okay, last to them. Okay, we are going to generate a them, but not from the, this is the last to them for if you have, but this one is restricted to I mean, this one is limited to 1 million, but this one no. Okay, so we are going to use this one, last to them pro. We are going to use the input directory that is last. We are going to select it last. Okay, no, it's, oh, sorry. Sorry. We have to do a change here because what we have stored is we have stored this under last. However, this has to be under other folder that is called split. Okay, so this one will be, so just take this 62, Control X, and then let's go to split and then paste it here. Okay, because this one has to be under split, not under last. Under last is the original one, under split are the all of the ones. If you are here with me, please type yes 4. If you are here with me, please type yes 4. Last them it creates from the point cloud, it creates a digital elevation model, okay, or it creates a raster file, okay, because the point cloud is actually just points. I mean, it's not even a spatial data. I mean, it's spatial data, but in certain form, but it's not compatible with GIS. So with last to them, we can create a them from that. Okay, if you are here with me, please type yes for. Okay, great. So let's do, now we can do the last to them, and the last to them will be to related to the directory of split. Yes, and then here we are going to do a filter because we are going to keep a ground, and number 2 is ground and number 8 is a key point. Okay, those are the ones, because actually since we are defining a drainage network, we are not interested in keeping the roofs of the, or the highest part of the vegetation or the roof of the houses. We are just interested in this, we are just interested on the soil. Okay, so that's why we keep 2 1. Okay, and then where we are going to store this is in save to a directory, and then we create a raster. Here on raster is where we are going to store our raster file. And that's it, we can run. And with that, it's creating a raster file. It's creating a raster file and the raster. So what does it mean? That here in our document folder, session 5, on raster, it's creating, but it's creating one raster from every, it's creating one raster from every point cloud. So it's creating 62 rasters, but there is no problem with that. Okay, so let's do this. Yeah, what is the advantage? The advantage of LIDAR is that is the definition. Okay, Be because like when you are working with raster data, you have a resolution of 30 meters, while here you can have a resolution of 30 centimeters, and actually you can represent the patterns of drainage of at urban. I mean, what it happens on the street, while in Amsterdam you cannot do it. Okay. Yes, so it's working. If you are here with me, please type yes 5. Okay, great. So it means that it has finished. So here I have all of my raster files. Yeah, but for every point cloud, it also creates a KLM. Actually, we have to get rid of the KLM. So we do delete not the TIFF, neither the TFW, but we need to get rid of this because this will make us some problems when joining the raster. Okay, yes. So these are all the TIFF files, and then you will have one TIFF file per every point cloud, and then with the TIFF, the TFW, and then you delete the KLM. If you are here with me, please type yes 5. Okay, if you are here, please type yes 5. If you are here, please type yes 5. Okay, great. So we are going to create a virtual. We can close everything because we have finished, and it is we have finished with the last thing, and then we can go on with the them with the with QGIS. So we are going to create a virtual raster. We are going to create a virtual raster, virtual raster of raster miscellaneous. Okay, and then we are going to insert here. We are going to look for add directory, whatever is here on raster. Okay, except this one, except the first two. Okay, I will do it again. Virtual raster, I will select a directory, add a directory, and then the directory will be rst. Okay, and then I will look for everything except the first two, because the first two are the ones that are from the other part. Okay, yes, and then so with here we can create a virtual raster. Well, let's type okay. Yes, great. Okay, and that's it. With that, I can join all the raster files. Okay, with that, I can join all the different raster files. And then with that, I can also say jump this restriction on the license. Okay, I can jump the restriction of the license. Okay, and then here I'm using a temporal file. Why I'm using a temporal? Because I haven't saved it to any specific file, and that's it. This is the temporal file, and this is the digital elevation model at surface. Okay, zoom to layer. Hey, something went up. I don't know why. Okay, this is the, well, it's loading. Okay, this is the, okay, so with from that there are some gaps here. The other day that I gave this course, I tried to fill those gaps and somehow I couldn't finish the exercise. Okay, so in this case I know that if I don't fill the gaps right now, I could make the demo go, but if I fill those gaps, maybe I haven't select the right tool, and then I couldn't fill those gaps. Okay, great. That's right. So let's let's do this. Yeah, let's do this. Fill things of one lieu. Yeah, and then okay, let's do the catchment definition of this by typing here fill sinks, because we are going to do a fill sinks of one lieu. We are going to fill the depression of the virtual. Okay, and the same as we have done with the other ones. Then we run. If you are curious, you can see which is the definition of this raster file. I will show you in a minute, because we are talking about match resolution. I think that is 5 centimeters, and with that you can do a lot on the definition of channel networks or whatever. Okay, this takes some time. You have any problem or okay? I think that we are working with 5 centimeters. Okay, great. So here we have, this is the fillet dam, and then we have as well the watershed basins. We have here the watershed basins, okay, and then we have here the flow directions, and this is what you are seeing here is the flow directions on at the street, and here you can find the, how do you say this, the drainage, the road drainage. This is amazing. I mean, what you can find or what you can do here with this, and the amount and the quality on that. Okay, finally what we are going to do is channel network and drainage basins. Channel network and drainage basins. Okay, but first I was going to tell you which is the resolution of this. This is not 83, some 5. This is in feet. This is 1 feet, 30 centimeter. 30 centimeter what you have the resolution here. Okay, and then I think that you can even decrease that. Okay, so let's go here to channel network. This is a field them. Yeah. No, the gaps are not considered like sinks. Why they are not considered like sinks? Because actually flow cannot go through a gap. So actually it will, okay, when they find a gap, it will, so say, surround the gap. Okay, and it will be a homework for you because you have here some gap filling. Okay, gaps, close gap with SPL line, because with that one it doesn't work the channel network, but it might work with these ones. Okay, okay, so here we go to the channel network and drainage basin, fillet them. Okay, so and from this we don't want this, we don't want this, we don't want this. So we want channels, we want drainage basins, and then we don't want junctions. And then here on channels we are going to save to file, to shape, and this will be channels, and then drainage basins, this will be basins, and then we run it. Okay, if I fill the gap with a closed gap, yeah, I find some problems. I mean, I couldn't finish the process, but you can play around with that. This is entirely new. I mean, I discovered it. Okay, so there is a lot of things to work with, and there is a lot of things to consider as well. Okay, so let's work with this. Okay, it's working. Yeah, this is a great question, Edis. That if we can insert sewers there. Actually, I don't know. Actually, yeah. It will be interesting to know where the sewers are located and to define the area of that sewer. Yeah, and then measure the flow on the sewer. But I think that is possible because we have to define the same upslope area as we have defined for the other one. However, we still have to do it. Okay. Okay, great. So here we can find the channel network, and then we can find the area of accumulation. This is the drainage, the road drainage. Actually, there is a sewer here. You can define the area of influence. There is some issues here with elevation. Okay, the gaps also plays a role. We can continue defining this, but if we define this with the roads, I mean there is a, I mean here you can find the houses draining through this, going through the street, and then joining this kind of, yeah, yeah, kind of, you can model the receptor here. Okay, is kind drainage receptors. Okay, well, it's promising what you can do with this on your reality. Okay, so that is, if you are here with me, please type yes 6, and that will be uh, everything from today. And if you have any question, let me know. Okay, if you are here, please type yes 6. If you have any questions, please let me know.